10-3. Area of a parallelogram. Very simple formula, but one that people do wrong a lot. It is just base times height. The reason people do it wrong a lot is they make the assumption that the base is always going to be on the bottom and that the height is whatever you want it to be. So that's why I gave you this first picture. First, we better make sure it's a parallelogram. And it has the markings that the opposite sides are parallel. And so we know that. And so we also know this one on the right side must be how long? Must be 5.4, and this one on the top must be 3.2. Now, the tricky part about parallelograms is the height. The height must hit the base at a right angle. So is 3.2 the height of this parallelogram? No, it's not. Do you think a lot of people just look at this and take 5.4 times 3.2? A lot of people do. Unfortunately, that is wrong. The height then is most definitely the 2.1 because there it is hitting at a right angle. So area equals. We'll put base there, and we're going to put height right here of 2.1. Now, the other thing is that the height will always hit the base at a right angle. The two will come together at the right angle. And so is 3.2 then the base? So the 3.2 is basically neither one in this problem. So the only reason I put it in there is to see if you would use it. There is no need for it here. So we know the base is 5.4 because there it is coming together at the right angle. And so you take those two times each other. And I don't think we need any rounding here because I don't think that's going to get too crazy on us. And it's definitely over 10. I think we can agree with that. And it is 11.34. And now to the part where I ask for the label. Meters squared. Which then leads to quite possibly the most important question I ask. And there is a stock answer that annoys me beyond belief. When I ask why is it meters squared, and the answer I get is because it's area. No, that's not why. That might be is what you taught before, but that's not why it's meters squared. Exactly. I took meters times meters, which is meters squared. Now that's where a lot of people get in trouble. What if there was centimeters on one of those and meters on the other? Your technical label would be meters centimeters or centimeters meters. That's why you always convert one so that they're the same. And you can do meters squared or perhaps centimeters squared. That's truly why that is squared, not because it's area. So that's a parallelogram right there. The one on the right is just a region. And what you need to do is divide it up into things you know how to take the area of. There is no one way of doing it. It's whatever you see. And I have had some people show me some very creative ways of dividing up this particular region. The most common one is just going down like this and creating basically 1, 2, 3 different areas. Okay, that's the most common. Again, not the only way. Okay, some people have kind of gone across with their lines, and some people have just kind of filled it in like this and just made 2 and subtracted out the stuff they didn't have. A lot of very creative ways of doing it. So let's just look at, I guess we'll call it region 1. Do we have both measurements for region 1? It's 8 feet by 4 feet, so we can find that one, and that is how much? 32 feet squared. And that's how I will read those when I read answers, is 32 square feet is probably how I'll read it. There's nothing wrong with saying 32 feet squared. I think that region 3 is probably the easiest one to get next, because how much is that one right down here? That's just 3 feet because it's the same as the top. So this one's just 3 by 13. Well, that's 39. And I also took feet times feet, so it's square feet. Region 2 is probably the most difficult, because we pretty much have to figure out how far is that and how far is that. Is it from here to there? Is that 14? No. From there to there, well, we know this much is 3 over here, and how much is this one on the left? It's 4. So how much is it from there to there? 7. Because it's 14 minus the 4 minus the 3 leaves you with 7. So this one so far is 7 by, now how about that one? It is 6 because this much over here is 8. We took away the 2, meaning it's 6 by 7, which is 42 square feet again. So we have 3 numbers. Which of those 3 is the answer to the entire question? Yeah, none of them. Because what do we have to do? Add them together, which leads us to another interesting situation. Yes, we know how to add the numbers. 32 and 42 is 74, plus 39 is what, 113? We don't have a problem with doing the 113. But then some crazy things start happening with the label. It's feet squared plus feet squared plus feet squared. Does it become feet to the 6th? Okay. It is just feet squared. Funny thing is most of you can handle it now, but if I put x's in place of the feet, you would struggle. What do? Oh, it's 32x squared plus 42x squared plus 39x squared. It's the same thing. Yet you would struggle on that one, and you didn't struggle on this one. Okay. Any questions on the first 2? Yes, I said first 2 because I know some of you already looked at the back and said there's nothing there. Well, that's because the copies didn't get made, but this will be more like college. We're doing notes the entire period, and you have to write stuff in by yourself. So go ahead and draw that one in now. The most common mistake people will make on this particular problem is that they see, oh, you're just trying to trick me. I just add the 7 and 3, so I take 10 times 5, and it's 50 square inches. That is unfortunately incorrect because you did not take base times height like it tells you. Now, we do know it's a parallelogram because it is in the directions. So we have to find base times height. Well, we know whatever that distance is right there, that's your height, which does actually make 10 the base. So that much you would be correct on. Now, you might think it's a typo that I didn't give you the height, but it's not. Because I know if this side over here on the left is 5, this one over here is 5, because again, we know it's a parallelogram from the directions. And basically what that creates is a right triangle, which if that's height right there, that is something you can figure out. I'm hoping this is a triple you're starting to learn fairly well to save yourself time. I think most of you know it is 3, 4, 5. If 5's in the right spot, is 5 in the correct spot? Yeah, it is the hypotenuse. But if you were confused, you could, again, go to Pythagorean theorem, and it really wouldn't take that long to get that far. You would then subtract 9. But again, I'm hoping you're starting to get pretty good at doing that square root. So technically h is positive and negative 4. The negative makes no sense. And so the h, or the height, is 4 inches. Again, hopefully you're starting to learn 3, 4, 5, 6, 8, 10, and a lot of those. And so your height is 4. So the answer here is that the area is 40 square inches, again, because you took inches times inches. If I took inches times feet, it's feet inches, or inches feet. Okay, so watch out for that. Actually know that stuff. All right. Now here's what I could do, though. I could have given you this problem. You don't have to write this down, but what if I didn't give you that 5? I guarantee this is going to happen, and all of a sudden, oh, that's a 60-degree angle right there. Which means this one down here, I just put the red dot in, is a 30-degree angle. Can you now get the height? Yes, either you could use law of sines by doing sine of 30 degrees over 3 equals sine of 60 over h. Or you could just use your cheat sheet, which says to multiply by square root of 3. Okay. Again, that's if you get a problem that looks like that. You don't have to write this down. But the base is still 10. Height's 3 square root of 3. You have to watch the directions at this point. If the directions say to leave it exact, you would write 30 square root of 3. It would still be square inches, though. Or if they ask you to do the rounding, you would go ahead and actually round that. So watch out for that. And of course, 45, 45, 90 is also a possibility you could see. In fact, I could put any in there because you do know law of sines, or you should know law of sines. Okay. Any questions on that? Okay, what you need to do now is get the last example in your notes. Give yourself a nice XY axis and graph it when you get that file. All right, and there it is, miraculously graphed. If you are listening to these notes, you may want to stop and actually graph that before you listen to the rest. The first thing we have to do, well, I think we can eliminate square and rectangle as possibilities because they're not right angles. But let's make sure it's a parallelogram. Are segments AB and DC guaranteed to be parallel here? Yes. How about AD and BC? Well, I would look at it this way. To go from A to D, you have to go down 3 and over 2, correct? To the right. And the same thing, is it down 3 and over 2 to get to C? So are the slopes of AD and BC the same? Yes, they are. So this is a parallelogram, which means I now have to do base times height. And here's where people get a little crazy sometimes. They say it really doesn't matter. They think that that would count as a height. Does that segment from B to A I just drew in, does that hit segment AD at a right angle? No, it doesn't. If you were trying to draw the height that way, you'd kind of have to come at an angle like this. Do you think that's kind of harder to figure out? I think that's very difficult to find out when it's much easier just to figure out that that's the height. And then if that's the height, this one must be the base. Much easier than trying to go the other way. And if you do that, height's probably pretty simple. It's what, 1, 2, 3? And the base is 1, 2, 3, 4, 5, 6. And so the area is 18. Well, do we know if that's inch paper or centimeter paper or anything like that? We don't. And so for now, we'll just put units squared, or U squared is fine. Once somebody tells us what kind of paper we had, then we can get more accurate. Any questions?